Today I'm going to talk about Karnaugh map or K-map. We know how to simplify a function by postulates and theorems and laws as we did in our previous lectures. We can use different rules to simplify any function. But there is a systematic way to find the minimum cost expression for a logic function. So when we simplify function f of a, b, c by laws, postulates, and theorems, and we get an answer, we're still not sure if our result is the simplest possible uh, equivalent of the circuit, or in the other word, we're not sure that if the result is the minimum cost. Minimum cost means less hardware, less number of gates. So we need to find a method, a way to make sure that we can easily determine and find a minimum cost expression for any a given logic function. So I here we say that the Karnaugh map provides a systematic way to find a minimum cost expression for a given logic function. Minimum cost means less number of gates, and of course the fastest possible gates. So we know what is min term. Okay, so we want to talk about different type of k maps which we work with min terms and max terms in these k maps. So the first type of k map is two variable k map. So we have two variable k map. Okay, so if we have this truth table a, b, and here is a function 0, 0, 0, 1, 1, 0, and 1, 1. We know that for 0, 0 we have min term number 0, m1, m2, and m3. And if we create a k-map, the k-map for two variable is in this form, a 2 by 2 table. For the columns we put a, for the rows we use b. Okay, no big difference if we use a and b, if we switch a and b, but always we put the first variable for columns and second or next variable for the rows. So a is 0, 1, 0, 1 for a and b. For the first cell, which is here, if we look, we see that a is 0 and b is 0. So which min term should be placed in this cell? Of course, m0. So m0 will be placed here, m1 here, m2 here, and m3 here. So this one is two variable k-map. So let's see what is three variable k-map. So here we want to learn three variable k-map. For three variables, of course, we need three inputs, a, b, c, and the function is here. So we start by 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 100, 101, 110, 111. And of course, we have M0, M1, M2, M3, M4, M5, M6, and M7. Because we have 8 midterms, our table has to have 8 cells. So we use this type of tables for 3 variable K-maps. This is the table. We use 4 columns and 2 rows. For the columns, because we have 4 columns, we can have 2 variables. So let's put A and B and C. C is 0 and 1. And for A and B, we start from 0, 0, then 0, 1, then 1, 1, 1, sorry, 1, 1, and then 1, 0. Why I didn't say 1, 0, and 1, 1? Because if any adjacent cell has to have 1 bit difference with its adjacent cells. So 2 adjacent cells cannot have like more than 1 bit difference. So if we look to this cell and this cell, for example, we see that both of them have C of 0. C is 0 for both of them, and B is 1 for both of them, and A is different. So okay, so this one is the rule. If we used 1 and 0, if we use 1 and 0 instead of 1 and 1, here there is a problem, because for this cell we have 1C, but if we look, we see that A is like difference for these 2 adjacent cells, and of course B also is different. So A and B. So A is 0 for one of them and 1 for the other one. B is 1 for one of them and 0 for the second one. So we are not allowed to write our truth table in this form. So the only way we can build a truth table is considering these rules, that each like 2 adjacent cells, they have to have only 1 bit difference. So here we say 1, 1, and 1, 0. And now if we put these minterms in this in this K map, we will have M0, M1, M2, M3, M4, M5, M6, and M7. If we look, we see that for the second row, C is 1. So for M1, M3, M7, and M5, C is 1. And if we look the same thing in the truth table, that's correct, because M1, M3, M7, and M5, all of them have C of 1. Okay? And for the last 2 columns, A is 1, and for the middle columns, B is 1. So it's very important. Okay? And the rule that I mentioned, I will write it down here for you. Only 1 changes, or 1 change is allowed from 1 adjacent column to the next. Okay. Now we see four variable k map here, four variable k map. We need like 16 cells, so we okay, so we use this k map. Okay, and A, B are here, C, D are here. So 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Let me copy this K map. We will need it later. Okay, we copied the K map and we can access it later if we need. Okay, that's fine. Okay, for variable k map, let's fill the k map. We will have m0, m1, m3, m2, m4, m5, m7, m6, m12, m13, m15, m14, m8, m9, m11, and m10. This one is a four variable k map. For the last two rows, we have c equal 1. For the middle columns, b is 1. For the middle rows, d is 1. And for the last two columns, a is 1. Okay, so this one is four variable k map. Now let's see five variable k map. Five variable k map. We go up to five variables. Okay, for five variable, we use like two tables. We combine two tables together. So one table is here. I put it here. The other table again is here. Okay, these two tables together is the k map for five variable, and here we need to change this columns value, and we say ABC, ABC, and we start from 0, 0, 0, 0, 0, 1. So we should careful that not more than one change in each adjacent columns. So 0, 1, 1, 0, 1, 0, the next one 1, 0, 0, 1, 0, 1, 1, 1, 1, and 1, 1, 0. Okay, one thing that I forgot to mention that is that like the corner of the edges of each tables also are adjacent. So M8 is adjacent with M0. So the edge, this edge is like adjacent with this edge. So like M14 is adjacent with M12 as well. This edge is like adjacent with this edge. Okay, so it's very important to know that the edges also are counted as adjacent. So if we replace the if we put the values for min terms, we will have min term number 0, 1, 3, 2, 4, 5, 7, 6, 12, 13, 15, 14, 8, 9, 11, 10, 16, 17, 19, 18, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and 31. Okay, so let's just see which variables are constant for different cells. So let's start by A. If we look to these tables, we see that for the second table, for entire second table, A is 1. Okay, A is 1. If you look, we see this A is 1. So for the other table, A is 0. Okay, and then we look to B, we see that for both tables, this next the last two columns have value of B. For C, the middle columns, C and of course C. For D, last two rows are 1 for both tables, and E, we see that the middle rows have the value of 1 for E. Okay, so we learned the K map, so we know how to put the min terms or replace the min terms in these K maps. So for example, if we have let's see some sample examples or some examples. For example, let's say we have this K map. And we have this function. A, B, or C, and we want to fill the K maps here. We see that this one is min term number 7, and this one 1 1 1, and this one is min term number 5. Okay, and now if we want to show this function in the K map, we say min term number 7 is 1, which is here, min term number 5 is 1, which is here, and the other cells are 0. And it's the way that we fill the table, okay, with ones and zeros. Of course, if we have in the form of product of sums, the zeros will be placed in the table, which I will explain later. And I mentioned that we can simplify the functions by K map. Okay, so if we look to this K map, for example, we see that for both of these min terms, C is What is the C value for both of these minterms? For both of these minterms, C value is 1. So we can say C is 1. What about A and B? For both of them, A is 1. So A is C, and B is different for both of them. So B for one of them is 1, for the other one is 0. So B cancel itself. So we have AC. So the simplified version of this function is here. This one is the way we simplify the function. I will tell you how to do that systematically. Few things that I should mention before give you the the terminology and the techniques you will use. The first thing we should know is a definition of literal, which is each appearance of a variable, either uncomplemented or complemented, is called literal. For example, if we have x1, x2 bar, x3, it has three literals, which are x1, x2 bar, and x3. If we have x1 bar, x3, x4, and x6 bar, we have four literals, which are x1 bar, x3, x4, and x6 bar. Okay, so this one is the important definition that we want to know. So what we do? The technique. The technique is here. Some rules. The first thing we should know, we know that like edges are adjacent as well. So we count edges as adjacent as techniques. Then group maximum number of cells with 1. With each adjacency. So find the maximum number of cells which are which have 1 in them, and then group them. It's very important to know that groups, so it's number 2, and we should note that groups must be power of 2. So we can group like one cell alone, 2 cells together, 4 cells together, 8 cells together, 16 cells together, 32 cells together. So we cannot group 7 cells. This group has to be in the form of 2 power of 2. Okay? When we group them, Repeat step 2, like we group another cells with like another adjacent cells together until each one on the map be included in at least one group. So here is very important that a cell can be part of several groups, but at least one. The next step for each group, determine which literals remain constant in each cell in that group. These literals when ANDed together form the product terms of sum of product function. Okay, let's just review. It might seem like a little complicated, so let's just review. The first thing I said that edges also are adjacent as well. We identify groups of one. We try to find the biggest groups, okay, the biggest groups, which have like as much as possible one inside that group. So we should notice that those like groups must be power of 2. The number of ones or cells with one should be in power of 2. So when we identify the first group with, for example, 4 cells, then we move and repeat this like grouping until all ones in the table included at least in one group. And I said that a cell can be part of several groups, and finally for each group we determine which literal remains constant, and then use the sum of product form to simplify it. Okay, let's see. Here we have these examples. Okay, here we have examples. We want to find the minimum cost. Instead of minimum cost, I use MC, which means minimum cost. Find the minimum cost sum of product form for the function. For the function is f of a, b, c is a sigma of min terms 0, 1, 2, 3, and 7. Okay, we don't need to like remember or try to memorize these tables. Okay, we can not just the min terms in these tables, we can simply find them when we solving the problem. Okay, here what is given is the function in the form of min terms. So what is min-term codes for 0? Of course, is 0, 0, 0. For 1 is 0, 0, 1. For 2 is 0, 1, 0. For 3 is 0, 1, 1. And for 7 is 1, 1, 1. Okay, we have three variables, so we need to have a K-map with 8 cells. So we draw this K-map, A, B, C, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. Okay, the first one is min-term 0. We see A, B, C. All of them is 0. So which cell has A0, B0, C0? Of course, this cell. Okay? So the second one, the second term is like A is 0, B is 0, C is 1. A is 0, B is 0, C is 1. So it's here. The next one, A is 0, B is 1, C is 0. It's here. The next one, A is 0, B is 1, C is 1. It's here. The last one, A, B, C are 1, so it's here. So the first, in fact, if I zoom in, the first two digits are column, and A and B, and the last digit is row, which is C. Okay, so and the rest of like the remaining cells are 0, of course. Now we want to simplify this function using K-map. I said that find, identify biggest groups of 1. If we look here, we see that these 4 are like one of the biggest group of 4 ones. We cannot say this like 6 because there is a 0 in this group, and of course the 6 is not power of 2. Okay, so this one is the first thing. So let's check. Are all the ones belong to at least one group or no? If we look, we see that this one still has no group. So we need to group it with like other cells to make the groups. So let's group this one with this one to build the second group. Why I didn't group these three ones together? Because 3 is not power of 2. Okay, why I didn't group it in this form? Because it's not like adjacent. Okay, they were not adjacent. All of them has to like adjacent together. Okay, so this one is the second group, and now that we have all min-terms included in group, we need to write the function. The first thing I should write here, I look to this part, f is equal to. For these 4 min-terms, which literal in fact is constant? For literal is constant. Let's see. What about C? For second row, for these two, C is 1. For these two, C is 0. So literal C is not constant for them. Okay. What about B? If we look, we see that for the first column, B is 0. For the second column, B is 1. So B also is not constant. What about A? If we look, we see that for all four minterms, a is equal to 0. So we say a bar. That's it. So all these four minterms combined together and simplified in the form of a bar. Okay? Now let's continue to the next part. For the next part, uh, C is constant for both cells, so we have C. What about A? For one of them, A is 0, for the other one, A is 1, so A is not included, the A is cancelled. What about B? B is 1 for both of them. For both of them, B is 1. So we say BC. Done. So we considered all minterms. So we say the simplified version of this function is a bar plus bc. Okay, what was this function at the beginning? This function at the beginning was f of a b c was equal to a b c plus uh, a bar b bar c bar plus a bar b bar c plus a bar b c bar plus a bar b c plus a b c. So we simplified this long function to this simple version. If we use the theorems, the postulates, the laws, and do simplification on this function, the simplest possible output is equal to this function. So using the K-map gives a systematic way to simplify the functions to the minimum cost version or format. Okay, now let's see another example. Find minimum cost sum of product for f of a b c is equal to sigma m 2 5 6 7. Okay, we create our K map. And also, if it helps, you can just say the second row has a C of 1, the middle two columns B is 1, the last two columns A is 1. So it can help. If we place these min terms in this table, as I mentioned, we will have 1 1 1 0. Sorry, 1 1 1 1. The other cells are 0. We keep them empty, so we can just put 0 or just leave them empty. So no matter. So we want to find the minimum cost function for this table. The first thing, can we group all these four together? No, because they are not like in the group of the group should be in the form of rectangular form, okay, including the edges, not like this shape. This is not a group. So we group these two together, and we group these two together. Do we need to group these two together as well or no? We can, but the output is not the minimum cost, so it's like not necessary. We shouldn't do that, because all the min terms are included in the group. Don't remember, I don't know if I mentioned or no, we should try to have the minimum number of groups, and all the minterms be like in a group, okay, be included in a group. So minimum number of groups. So I can say, for example, this I want to group with this one alone. Okay, that's fine. Is the answer correct or wrong? Its answer is correct, but it is not minimum cost. Why? Because we didn't find the minimum number of groups. The minimum number of groups is here, which is two groups. Okay, minimum number of groups. Each group, the maximum number of terms. Okay, so minimum number of groups, maximum size for each group. Okay, so now that we reached to this point, we can write the function. Function is for the black one, for the black group. We see that C is C. Let's start from A, B, and C. A for the first one, A is 0. For the second one, for the first one, A is 0. For the second one, A is 1. So A will be cancelled. What about the B? For both of them, B is 1. So we put B. What about C? For both of them, C is 0. So we say BC bar. Plus, for the red one, A is 1 for both of them. We keep it. B is different, so we cancel B. C is 1, so we keep C. So the simplest possible form of sum of product is here. Other example. Minimum cost sum of product of f of a, b, c is equal to sigma m 0, 1, 2, 3, 5, 7. Okay, we create the k-map a, b, c 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. So again the same codings, okay, which I told you. So 0 is 0, 0, 0, 1 is 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. Okay, so we put these values in the k map, so we will have 1, 1, 1, 1, 1, 1. Okay, let's group them. The least number of groups, the maximum size for each group. So this one is one group, and we can group these two together. So we say, okay, we have the minimum number of groups, but I said also the maximum size for each group. Of course, the minimum number of groups is 2. Okay, that's correct. What about the maximum size of groups? Did we consider the maximum size of each group? No. Of course, we can, for the green one, we can say we group these 4 together. Okay, so there are the maximum number of maximum size for each group. So 2 conditions: less groups, biggest groups. Okay, so we have these two rules which we should like consider. And now we can say function is for the red one. For the red group, if we see that C is different for a different min term, so C is not in this term. Also B is 0 and 1, so B is cancelled. The only literal which is constant for the red group is A bar. A bar. What about green group? So if we look to green group, we see that A and B are changing for these cells, but C is always equal to 1. So function is the simplest version of this function is A bar plus C. Let's see the other example. Example, minimum cost sum of product for A, B, C, which is sigma min terms of here the function is in this form: A bar, B bar, C bar plus A, B bar, C plus A, B bar, C bar plus A bar, B bar, C. Okay, so let's create the K map. It's eight, three variables, eight cells. So it's A, B, C, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Which cell? So, okay, A, 0, B, 0, C, 0 is here. A1, B0, C1 is here. A1, B0, C0 is here. A0, B0, C1 is here. Okay, we want to find the simplified version of this group. Again, I said that the middle part is B, the second row is C, and the last two columns are A. Okay, let's see what we have here. We can say, okay, let's group these two together, these two together. Is there like the best solution? We can say, well, we have two groups because we cannot group them in like in this way, but it is not the answer because based on the rules, I said that edges are adjacent as well. So it means that this edge is connected to this edge. They are adjacent. So we can say these two can be grouped with these two. Okay? So these two. So because the edges, as I'm showing with those green zigzags, there are adjacent. They are connected. Like just let's consider this table. We roll it like a cylinder. So these two edges will be reached together, and they are considered as adjacent. So for this group, so we have just one group and we want to write the function. The function is, so let's look to these four cells. What about C? Is C, a literal C, constant for all these minterms? Of course no, because C for some of them is 0, for some of them is 1. So C is out of the like equation. What about A and B? If we look, we see that A for first column A is 0, for the last column A is 1. So also A is of the terms. The only terms is like remains is B, which we see B is 0 for all four cells. So F is simply B bar. Okay, so if we simplify this function, we will have B bar. Okay, so now let's see some examples for variable with for the functions with four variables. So far, all these functions had three variables. I want to show you some functions with four variables. Um, Minimum cost sum of product for function A, B, C, D, which is sigma of min terms, 2, 3, 5, 6, 7, 10, 11, 13, and 14. Okay, now we need to put these min terms in the table. I remember that I copied the 4 by 4 table. Let's see if I have it here. Okay, yes, we do. Good. So, okay. So because these are four variables, each code has to be shown by four digits. So 2 is 0010, 3 is 0011, 5 is 0101, 6 is 0110, 7 is 0111, 10 is 1010, 11 is 1011 if I'm correct. Yes, 13 is 1101, and finally 14 is 1110. These are the minterms which place in the we need to place in the table. Try to play. I will pause the video and try to put these variables in the K map and then compare your result with my solution. Okay, so let's see what are the minterms locations in the K map. Let's compare your result with my solution. We will have minterms in these cells here, 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 and here. Okay, now it's time to find the groups and group the numbers together. The first thing, we cannot group these six minterms because it's 6, it's not power of 2. So the first group which we identify is this one. The second group is these two and these two. Third group is we have one minterm here, but in order to keep our group as large as possible, we group all these four minterms together. And finally, we have two ones here which group together, and now all minterms are in at least one group. Okay, now let's write the function. The function is equal to the red one. For the red one, a is constant, which is a bar, b is changing, c is constant, which is c, d is changing, so it's a bar c plus the green one. We see that a is changing, b is constant, it's b bar, and c is what about the and c is c is constant, and d is oh, let me do from the beginning. Sorry, for the red one, a is constant with a bar, b is changing, c is constant, it's c, d is changing, so it's a bar c, which is correct. For the green one, a is changing, b is constant, which is b bar, c is constant, which is c, d is changing. For the black one, for this black, a and b are changing, c is constant and d is constant, c bar d. And for the other black, which is consists of two cells, a is changing, b is constant, c is constant, d is constant. Okay, so this one is the simplest possible sum of product form for this function. Okay, let's see the next example. Minimum cost sum of product for this function for f of a, b, c, it's sigma of min terms 0, 4, 8, 10, 11, 12, 13, 15. Okay, I recommend you to pause the video and try to complete the K-map and then compare your result with my solution. Okay, if we fill this table with those minterms, we will have 1, 1, 1, 1, 1, 1, 1, 1. Let's group them. These four, of course, together is one group. These two are together, one group, and these two are together, another group. So we cannot have less than three groups. Is the minimum number of groups, and we keep the group as big as possible. So we have no other option. So we can say F is equal to, for the red one, A and B are changing, and we have C bar, D bar. For the blue one, B and C are constant, so our AB, C is changing, D is constant, ABD, plus for the green one, A and B are constant, so it's AB bar. Why it's AB bar? Because it is 1, 0, so it's AB bar. C is constant, C and D is changing. Okay, so this one is the minimum cost for this table. The next example, minimum cost sum of product for f of a, b, c, d, which is sigma m 1, 2, 3, 5, 7, 11, and 13. Okay, so for this one, if we fill the table, we will have 1, 1, 1, 1, no, not here, 1, 1, 1, and 1. Okay, we need to group this. So be careful about this one. It's a little complicated to finding the biggest group and the minimum number of groups. So this one is, of course, the first group. The second group, the only two which I can consider are here. The next one, I want to see if for this one, what can we do? We can group these two together. And for this one, should I keep it alone? Of course, no, because edges, as I mentioned, are adjacent. So we can say this one and this one. You see, this one is like belongs to two groups. That's fine, okay, because it's supposed to be belongs at least to one group. Now write the function. Function is equal to, first the red one. A is constant, which is A bar. B is changing. C is changing. D is constant, which is D. The blue one, A is changing, B is constant, is B, C is constant, is C bar, D is constant, is D. For the green one, A is constant, is A bar, B is constant, is B bar, C is constant, C, and D is changing. And finally, for the black one, if we look to these two cells, we see that A is changing, B is constant, is B bar, C is constant, D is constant. and this one is the minimum cost sum of product for this function. Let's move to the next example. F of A, B, C, D is equal to sigma M 1, 2, 4, 6, 9, 15, and here is the solution. Okay, if we fill this table, we will have 1, 1, 1, 1, 1, and 1. Okay, let's just group them. The first group, here we have just 2 minterms. What about this one? This one is alone. No adjacent. These two are together. This one and this one. And these two are together. This one and this one. So we considered all groups, and if we write the function is for the given one, A is changing, B is constant, which is B bar, C is constant, D is constant. For the blue one, we have a single cell, which is A, B, C, D. The other group, A is constant, A bar, B is changing, C is constant, D is constant. And finally, for the red one, A is constant, B is constant, C is changing, D is constant. Okay, so this one is the simplest sum of product for this table. And the last example for 4 by 4, it's not an example, but just something that we should notice. So let me show you. In this kind of tables, if we have a function, if we have this function, let me just write. If we have f of A, B, C, D is equal to A bar, B bar, C bar, D bar plus A, B bar, C bar, D bar plus A bar, B bar, C, D bar plus A, B bar, C, D bar. If we try to put these minterms in the table, we will have 1, 1, 1, 1. Okay, in this case, we can say this one is adjacent with this one. Also, this one is adjacent with this one. This one is adjacent with this one. This one is adjacent with this one. So you see, all of them are adjacent. So, like the corners, where is like undo. Okay, that's fine. For the corners, like this, we can say this one and this one and this one and this one are in a one group, because I showed that all of them are agents. And then so the function is, if we look, we see that for these two and these two, B is constant and A is changing. Because A is changing, A is cancelled, B is constant, so we say B bar. And in this direction, if we look to these two and these two, we see that C is changing and D is constant, so it's D bar. So this function can be simplified to this form. Okay, so this one is like one of the positions that you might need to deal. Okay, let's see one 5 by 5 5 by 5 not 5 by 5 5 variable function. Minimum cost sum of product for this function. F of A, B, C, D, E is equal to sigma of min term 1, 3, 4, 9, 11, 12, 13, 15, 17, 19, 22, 25, 27, 29, 30, and 31. So we want to find the minimum cost of this function. First thing, all of these variables in term, all of these products are 5 digits. So for example, for number 9, uh, we need to use it with show it with 5 digits. So it's like 1 and 8. So this one is number 9. I used 5 digits. Number 3 is 00011. Okay, so it's the way we need to show all these variables. And let me paste the table. As I mentioned, for 5 variable tables, we need 5 variable k-maps. We need to use 2 tables which are connected to each other. Okay, and I erase these columns. And let's go back to 5k, 5 variable k map. Let me check. Yeah, in 5 variable k map, when I was talking about 5 variable k map, I think I should have changed this to as well. So they were not CD. A, B, C, D, E, and D, E. Okay? I just fixed these 2 parts. D, E. Okay, let's go back to our example. Okay, here is our example. A, B, C, A, B, C, D, E, D, E, 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, 1, 1, 1, 1, 1, 0. Okay, and we know that these are D, D, this is C, C, entire second table is A, here is B, here is B, and here is E. Okay, so this one is like the 5 variable. Let me let me copy this table for the next example. Okay, so if we fill this table with these variables, I told you how to map these numbers in these tables. For example, I'm going to do one of them. For example, 19. 19 is of course 16 plus 2 plus 1. So we say it is 16, 16, 8, 4, 2, 1. This one is 16. Okay, so this one is 16. So these three are A, B, C, and these two are D, E. So A, B, C should be 1, 1, 0, 1, 0, 0. Let's find 1, 0, 0 from here. 1, 0, 1, 1, 0, 0, yeah. 1, 0, 0 is this column. Let's find DE, find 1, 1. 1, 1 is this row. So this cell. So this cell is 19. Okay, so it's the way we place the min terms in the tables. Okay, let's go ahead and fill the table with all variables. So this one was 1. Let me 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. Okay. So in like 5 variables, when we have 2 groups, try to find the identical groups in both tables first. Identical groups in both tables. So if we look, we see that we have a group of 4 here. We have exactly the same group here. So this group and this group together are one group, because they are exactly identical in both groups. Okay, so it's very important. If we have exactly identical groups in both tables, we can consider them as a single group. Next one, let's say these two and these two. Do we have identical group in the table number 2? Yes, exactly same. So all the blue groups are same. So this one is the second group. So we identify 2 groups. Third group is here. Do we have the identical identical group in this table? No. So we keep it alone. And of course we have another one here. Do we have the same identical in the other table? No. So we keep it alone. And now done. We just need to write the function. Function is equal to first the given one. For the given one, if we look to the given one, because the given one is in both groups, so it has first thing I should tell you. So it's not here, it's not D. I don't know why. Here's A, not D. So because in both groups we have identical group, and one of the group in both tables, sorry, if in both tables we have the same identical group, and second table has A of 1, the first table has A of 0, so A is cancelled. Now what about B? We look for all of them. For all of them, B is 1. So we say B. What about C? If we look to C, we see that no, C for some of them is 1, for some of them is 0. What about D? D also changing. What about E? E is constant, so it's PE. PE is for the given group. Let's go to the blue groups. For the blue groups, because again there are in both tables there is no A, because second table has A1, first table has A0, and we have identical groups in both tables. A is cancelled. What about B? B is different. So if we look, we see that B for some of them is 0, for some is 1, so B is also cancelled. What about C? For all of them, C is 0, so we say C bar. Okay, C bar. What about D? D is changing, D is cancelled. What about E? E is constant, so it's CE. The next one, the red group. The red group, if you look to the red group is only in the second table. So A is constant, so it's A. What about B? B is changing. C is constant. D is constant. E is constant. So it's A, C, D, E bar. Plus the black one, it's only in the first table. In first table, A is A bar, so it's A bar. B is changing, C is constant, D is constant, E is constant. So this one is like the simplified or minimum cost for this table. Okay, so let's see the last example for a K-map in the form of sum of product. Example, we want to find minimum cost sum of product of f of a, b, c, d, e, which is sigma m of 1, 3, 9, 11, 12, 13, 14, 15, 17, 18, 19, 25, 27, 29, and 31. Okay, so let's just place the min terms in the tables. If we do that, we will have 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. First, try to find the biggest groups which are identical in both tables. So I consider these 4 min terms and these 4 min terms together as a single group. The next one, I consider these 2 with these 2 and these 2 with these 2 exactly identical in both tables. The next one is these 4 together. We don't have the same thing in the other table, so it's not like identical in both tables. And the last one is these 2 ones. Okay, so let's just write the function. The function is equal to first the green one. For the green one, because it's in both tables, A is cancelled. What about B? B is 1 for both of them. What about C? C is changing. C is cancelled. What about D? D is changing. D is 0 and 1 is changing. What about E? E is constant. So it's BE. Next one, the blue one. The blue one, it's in both tables. There is no A. What about B? There is no B because B is 1 and 0. What about C? C is same for all min terms and it is C bar. What about D? D is changing. What about E? E is constant. So it's C bar E. For the red one, for this red, it's in one table, so A is in the term, in the product, so it's A bar because it's first table. Second table has A, the first table is A bar. So it's A bar. What about BC? So of course is B and C are same. What about D and E? D and E is changing in all of them. So there is no D and E. And finally, the last term is only in one table, so A is in the product. What about B? Yes, of course B is same, it's B bar. C is same, it's B C bar. D is same, it's D. E is changing, and so this one is the simplest circuit, minimum cost sum of the product for the function. Okay, next lecture I will talk about the like minimal product of sum form from K-map. So far we discussed sum of product, and then in the next lecture I will talk about product of sum.